So, hello everyone. Today I am going to take you inside one of the most important innovation in computing, which is 3D stacked memory architecture, which is a processing near memory, also also considered as the future of computing. So, before we get started, I want you to pull out your phone and scan the QR code at the end of the presentation. You will at the end of the website, you will find a QR using which you can see the 3D stack memory architecture in augmented reality form. So please try that out. So now let us get to our work. So firstly, what is the issue? The problem. Uh, this is a traditional case where you can see the blue is the uh, this is the I mean, to be honest, this is the traditional computer motherboard, but this is better way to understand. This is a CPU which is far away from the RAM memory, which is very far away from RAM memory. So when data travels from CPU to RAM memory, it takes the delay latency for from 50 to 100 nanosecond. You might think 50 to 100 nanosecond is very less amount of time. What would it make any change? But here in this case, when we have something around 4 billion cycles per second, instruction of 4 billion per billion cycle per second, so it makes a huge impact here, impact of hundreds of seconds. So it was a very big issue for any engineer. So in at that time engineer used to call this as a memory wall. uh, with time the processor got better, but we still had the same issue because of the distance between them, the traveling of there was a latency delay. So this became a bottleneck. That's why it has been written memory bottleneck here. So now we get to our solution. So how did we solve this out? uh, So we thought that why should we place both them apart centimeter? We can just stack them. So we just this is here in the image. The purple part is the what is a processor, and the four above chip are DDR sorry, DRAM. Very sorry, DRAM connected to it in a stacked way. So now it is not something about centimeters away, it is just meters away. Uh, I mean micrometers away from each other. So the latency delay decreases. So now the latency delay from 50 to 100 nanoseconds becomes 1 to 5 nanoseconds, which is a huge change. So you might be thinking how much improvement we got. We got 20 times better from the last version. But you might be thinking how we connect. So we connect to it using through TSV, which we call through silicon via. You can see the through silicon via here. These are the cylindrical cylinders which are placed vertically. These are copper cylindrical cylinders, which can be in thousands of amount, connecting the four DRAMs to the processor. It acts like a lift, which plays data up and down with nearly a zero resistance. So higher bandwidth and much lower power consumption. Uh, so now what is next? What are the next level changes we made further? So traditionally, this one is processor and one is data storage. So both are different. But as we evolve, as uh, the computing became next level, we tried to implement the processor inside the storage unit. Like we memory, I mean we call it PIM, which stands for processing in memory. So this green board, the green board is the which contains PIM at the center. Okay, so data never leaves the chip. Here we compute the data at the place where it has been already stored. So data do not leave the place, we just process it there only. So the distance criteria just cut out, which energy okay, so it reduces the energy consumption by 70%, and makes the performance 10% better, 10 times better to be honest, which is very high performance. So energy efficient, no movement as data, we just process the data at the place where it has been placed, and latency already automatically get reduced. So now today in real world, like how futuristic we have become to be honest. So let me take you an example of chip of NVIDIA H100. It is the chip that powers ChatGPT and Google Gemini. Uh, it is GPU core. You can like this is the chip. The H100 contains HBM3 chip, which is a GPU core. You can see four teal stack. These are the four teal stack. In between there is a processor, which has a very high bandwidth memory stack. Now, what is special in this HBM3? This HBM3 delivers 1200 gigabytes per second bandwidth. You might think how good it is. Just think about it. Our DDR5 laptop RAM module gives us 100 gigabyte per second bandwidth, while this gives 1200 gigabyte per second, which is 12 times greater. Just look at it, which is 12 times greater than earlier what we had. So, now let me talk about something about AMD Instinct MI300, which is better than H100 of NVIDIA. It combines CPU, GPU, and HBM3. It combines all of them and integrate all memory all in one. So there will be 70% less power consumption and it becomes 10 times faster. Okay, so let me just summarize all this in a simpler way. So what we have learned today is 3D stack memory solve the memory wall by stacking the DRAM above the processor. Simple, using the TSV connection, which stands for through silicon via. Okay, so what are the further steps we took to make it better? So we introduced embedded computing units within the memory itself. So this had made it 10 times faster. There is 70% less power consumption, and the bandwidth also become 12x, 12 times better than the earlier one. This is architecture powering every major AI system. I mean, this architecture mostly power every AI system in the world currently. So now please just try to scan the QR and check the augmented reality from your phone camera. Thank you. So here now we are testing the augmented reality. Let us just try to test it out. We scanned the and launched the DVR app. It would take some seconds, and yep, here are here is our augmented reality. Or that is the issue that we need to keep the QR at the middle to check it out. So here, okay, at the first image you can see the issue that has we have been talking about, which is about the distance between our memory and processor.
And the second image, the I was talking about the top left image. Then at the top center we use the 3D stack. Then we introduce the pim at the fourth image, just the right center image. And how the traditional data storage and processing were combined together, and the HBM3 GPU changed it all. And this is how everything changed. I hope you like the video. Thank you.